we are talking about hybridization, right? sp, sp2, sp3 hybridization we have done. Now today we will discuss sp3d hybridization. Okay, so in sp3d hybridization there is one s, 3p and one d orbital that is involved, and its best example is PCl5. Okay, so in PCl5 phosphorus is going to form 5 bonds. Now what is the electronic configuration of phosphorus? 3s2 and 3p3. Okay, so we need 5 unpaired electrons because phosphorus is going to form 5 bonds with chlorine. So first we write ground state of phosphorus. So in ground state of phosphorus we have 3s2 and 3p3, right? So in 3s2 and 3p3, in ground state of phosphorus it has only 3 unpaired electrons, so it is able to form 3 covalent bonds and with 1 lone pair, but we need 5 valence electrons. That means from 3s and 3p, next one is 3d, right? 3s, 3p and next is 3d. Okay, so phosphorus and B active, देखो रालम एंड वेदेही उन्होंने इलेक्ट्रॉनिक कॉन्फ़िगरेशन से सिर्फ वेदेही ने लिखी, कोई बात नहीं, अगर दूसरे ने लिख भी दिया यू शुड राइट, ठीक है, इट इज ओपन सोर्स, यू आर नॉट पेइंग फॉर दैट, है ना? चैट बॉक्स में लिखोगे थोड़ी किसी को पे करना पड़ेगा, जो दे रहे हैं वो तो दे ही रहे हैं, है ना? इसलिए try to write as much as possible. So it should be in the excited state, one of the electron from 3s should be promoted to 3p. Okay, so say these 3 electron remains as such, and one of the electron from 3s is shifted to 3d. One of the electron from 3s is promoted to 3d, so that phosphorus should have 5 unpaired electrons. Okay, after getting these 5 unpaired electrons, these orbitals undergo hybridization, 1s, 3p and 1d. So sp3 hybridization takes place, and each sp3 hybrid orbital overlap with chlorine, 3p orbital of chlorine. So in this way we get 5 bonds. So out of these 5 bonds, 3 are arranged in a trigonal planar shape, and remaining 2, they are one above the plane, other is below the plane. So these are equatorial bonds and remaining 2 are axial bonds. Okay, equatorial and axial. Say these 3, tell me what is the angle between equatorial and equatorial bonds? इसको E से, इसको भी E से डिनोट कर रहा हूं मैं, तो वेरी गुड, इक्वेटोरियल और इक्वेटोरियल के बीच में एंगल है 120 डिग्री, राइट? एंड व्हाट इज द एंगल बिटवीन एक्सियल एंड एक्सियल? 180 डिग्री. एंड व्हाट इज द एंगल बिटवीन इक्वेटोरियल एंड एक्सियल? इट इज 90 डिग्री. नाउ टेल मी, repulsion is maximum when bond angle is minimum. Repulsion is maximum when bond angle is minimum. Right? So repulsion is maximum between equatorial and axial. So we will consider these bonds. Okay. Now tell me, equatorial bond. For equatorial bond and axial bond. Yes, tell me. For equatorial bond, how many axial bonds are there at 90 degree? 2. That means there are 2 90 degree bond pair repulsion. Right? There are 2 90 degree bond pair repulsion for equatorial bonds. For axial bond, how many equatorial bonds are there at 90 degree? 3. For each equatorial bond, there are 2 90 degree bond pair repulsion. Okay. And for axial bond, there are 3 90 degree bond pair repulsion. Right? Okay. That means repulsion on axial bonds is more. Repulsion on axial bonds is more than that of equatorial bonds. That's why axial bonds are longer than equatorial bonds. So keep in mind, in this case, we can say that axial bonds are longer than that of equatorial bonds. So if there is a question why axial bonds are longer than that of equatorial bonds, you can write like this. Okay, that axial bonds have more 90 degree bond pair repulsion than that of axial equatorial bonds. Okay, I think you can do it. कर लोगे अब? Next करें. So now sp3d2 hybridization. sp3d2 hybridization. For example, take SF6. Yes. And what is the shape of this molecule? You have already done. sp3d shape is trigonal bipyramidal. Okay. Yes, you are right, Ralam. You are talking about SF6. Huh? SF6 has octahedral shape. Okay. So sulfur in ground state. First we will write configuration of sulfur in ground state. So sulfur in ground state has 3s2 and 3p4. 3s2, 3p4. Right? So it has only 2 unpaired electrons. But how many electrons we need? how many electrons we need? We need total. Yes, how many electrons we need? We need total valence electrons too. There are 6 valence electrons, beta. 2 is valency. It is not valence electrons. 2 is valency or valence of sulfur, right? But number of valence electrons are 6. Now, to get 6 unpaired electrons, obviously we have to use sp3d orbital. Good, beta. So, one of the electron from 3s and one of the electron from 3p are shifted to 3d. 1, 2, 3, 4, 5, 6. Sorry, there should be 5d orbitals in this. Okay, so it is like this. So all the 6 unpaired electrons undergo hybridization. sp3d2 hybridization takes place. sp3d2. Okay, so by this sp3d2 hybridization, each orbital overlap with 2p orbital of fluorine. Each will overlap with 2p orbital of fluorine. Okay, so when they overlap with 2p orbital of fluorine, they are arranged in octahedral shape. Sulfur 1, 2, 3, 4, 5 and 6. So fluorine are arranged like this, all have 90-degree angle. 4 in the same plane, 1 above the plane, 1 below the plane. So there is octahedral shape. Right? So this is about SF6 and sp3d2 hybridization. 2p orbital of fluorine overlap with sp3d2 hybridized orbital of sulfur. Okay. Next is, that is last, sp3d3 hybridization. For example, in IF7. IF7. Okay. So in IF7, can you tell me? IF7 में how many bond it should form? You know, iodine. See, fluorine, chlorine, bromine, iodine. If you don't know the electronic configuration, use this method. You know, in fluorine there is 2s and 2p. So in chlorine, that you also know. In bromine there is 4s, 4p. So in iodine there is 5s and 5p. Right? बेटा अलग से लगा रखा है, क्या हो गया? कोई सुनाई नहीं दे रहा है ढंग से? ऑडिबल नहीं है? सिद्धार्थ, टेल मी. कोई बोल दो, ऑडिबल है या नहीं? अच्छा, साउंड क्लियर है? ओके ओके ओके। अच्छा, जस्ट यूर, आप बाद में फोन कर लेना ना सिद्धार्थ, ठीक है, हम बात करेंगे डिटेल में। ओके, चल, तो अभी ये कर लेते हैं। सो देखो, इन आयोडीन, यू नो, आयोडीन हैज 5s and 5p, 5s2 and 5p, 5, right? Because you know fluorine is 2s2 2p5, chlorine is 3s2 3p5, so bromine is 4s2 4p5, iodine is 5s2 5p5. That's it, right? So from that we should know the configuration of iodine. Now because we need 5 unpaired electrons, so obviously we will use 5d to promote the electrons. This is ground state of iodine, right? So when iodine is in excited state, one of the electron from 5s and 2 electrons from 5p, that is shifted to 5d. Okay, so 3 electrons are shifted, and now we will get the desired number of unpaired electrons, and hybridization is sp3d3, sp3d3. Okay, so sp3d3 hybridization takes place. sp3d3 hybridization हो गई। अब इसके साथ साथ क्या हुआ है कि हर एक जो है दैट ओवरलैप विद 2p ऑर्बिटल ऑफ फ्लोरीन। डन। सो iodine, there are 5 fluorine form the pentagon and 2, one above the plane, other is below the plane. In octahedral, you can see in octahedral all the angles are 90, all the angles, yes, रालम, yes, octahedral में सारे एंगल 90 होते ही ना, हाँ होते ही हैं, ठीक है, all angles are at 90 degree because 4 are in the same plane, so they are at 90 degree. One above the plane, that is at the 90 degree, below the plane, that is also at a 90 degree, so all are at 90 degree. Okay, done. Now in this case, tell me angles. So the bonds which are in the same plane, that is at 72 degree and 90 degree. So there are two types of angle, that is 72 degree and 90 degree. And what is the shape? What is the shape of the molecule? It is pentagonal bipyramidal. It is pentagonal bipyramidal. Just like trigonal bipyramidal. In trigonal bipyramidal, there are 3 bonds in the same plane, trigonal and bipyramidal. On the same line, it is pentagonal bipyramidal. Okay. Got it? Any doubt? Yes, beta. कर लोगे? Okay, no doubt. So let us do next question. Okay, H2O. ओके 72 कहाँ बेटा? ये जो 5 है एक ही प्लेन में है तो ऑब्वियसली पांचों में कितना एंगल होगा? 72। ये 5 के 5 जो है वो 72 डिग्री पे है सेम प्लेन में, ठीक है? और एक ऊपर है ना और एक नीचे, ठीक है ना? तो उनके बीच में कितना एंगल होगा? इन पांचों के साथ इसका एंगल 90 डिग्री और नीचे वाले का भी 90 डिग्री, समझे? तो 72 डिग्री बिटवीन द प्लेन ऑर्बिटल्स बॉन्ड्स इन द सेम प्लेन। 5 जो बॉन्ड्स हैं है ना, ये 5 1 2 3 4 और 5, इन 5 के बीच में एंगल है 72 डिग्री। और ये जो दो हैं, वन अबव द प्लेन वन बिलो द प्लेन, दे आर एट 90 डिग्री। तो अब बात करते हैं, ये हो गया अपना। अब हम बात कर रहे थे कि H2O। अब H2O में you should form 2 bonds. So oxygen in ground state, तो ग्राउंड स्टेट में क्या होता है? 2s2 and 2p4. We need 2 unpaired electrons. So already it has 2 unpaired electrons. It has 2 unpaired electrons, right? It has 2 unpaired electrons. तो 2 unpaired electron already हैं, और याद रखना lone pairs are always hybridized. So it undergoes sp3 hybridization. sp3 hybridization हो जाएगी, ठीक है? तो 2 sp3 hybrid orbital form overlap with 1s orbital of hydrogen, है ना? ये ऑक्सीजन 1 2 3 and 4. There are 4 hybrid orbitals. Out of 4, 2 have lone pair and 2 have 1 unpaired electron, right? So this one overlap with 1s orbital of hydrogen. Let's write, sorry, 1s orbital of hydrogen. They are sp3 hybrid orbitals. It also overlap with 1s orbital of hydrogen, right? So in this way, in water, oxygen has 2 lone pairs and 2 bond pairs. So due to the presence of lone pairs, there is lone pair repulsion, and which repel the bond pairs. So bond pair come closer, because according to Vesper theory, lone pair repulsion is greater than lone pair bond pair repulsion, which in turn greater than bond pair. Done. So according to this concept, bond angle decreases. So bond angle is less than tetrahedral. It is round about 104.5 degree. Arrangement is tetrahedral, but shape is See, arrangement is tetrahedral, but shape, because of the presence of lone pairs, shape is bent or V-shaped or angular. Okay, bent or V-shaped or angular. Okay, now NH3. In NH3, you know, nitrogen should form 3 bonds. So nitrogen has 2s2, 2p3. Already it has 3 unpaired electrons. So at the very moment they undergo hybridization, sp3, 3 sp3 hybrid orbital overlap with 1s orbital of hydrogen. So there are 3 bond pairs and 1 lone pair, right? Okay. So nitrogen has 1 lone pair. You can write like this, or simple dots serve the purpose, and 3 orbitals with 1 electron each. 3 sp3 hybrid orbital with 1 electron each, that will overlap with 1s orbital of hydrogen. Okay, so it is 1 lone pair and 3 bond pairs. So again, due to the presence of lone pair, bond angle is less than tetrahedral. It is round about 107 degree. So it is trigonal pyramidal. So this is all about hybridization. So 24th question. 24th question जो है वो है what is meant by hybridization. We have done it. I will write the question. What is meant by hybridization of atomic orbitals? It is completely theoretical. We have done, and describe the shapes of sp, sp2 and sp3 hybrid orbitals, so that you know. Okay beta, 24 start karna hai na. So we have done it in the last lecture. We have completed this topic, what is meant by hybridization of atomic orbitals, and describe the shapes of sp, sp2 and sp3 hybrid orbitals. Mixing of atomic orbitals with slightly different energies so as to redistribute their energies to form new orbitals of equivalent shape and energy, and those are called hybrid orbitals. Very good. And What is the shape of sp? That you have done actually. What is the shape of sp, sp2 and sp3? Linear, trigonal planar, tetrahedral. Very good, great effort. So 25th question. Very good, Abhay. 25th question we have to do. Question is, what is meant by, okay. Next question is again, I will write on the same. What is meant by hybridization of atomic orbitals? Okay, I will erase rest part. Okay, first part is same. Okay, what is meant by hybridization of atomic orbitals? And what is the change of hybridization? What is the change in hybridization? Change in hybridization, if any, of the aluminium atom in the reaction तो रिएक्शन है बेटा AlCl3 plus Cl negative to give AlCl4 negative. Yes, so tell me, what is the is there any change in hybridization? Say aluminium is attached to 3 chlorines. Aluminium has 3 valence electrons. So it is Al, Cl, Cl. Okay. And in AlCl4, it is Al, Cl, 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 1 negative. Okay. So now tell me, is there any change in hybridization? Is there any change in hybridization? Yes, there is a change in hybridization. Say in AlCl3, chlorine is attached to 3 atoms. There are only 3 bond pairs and no lone pair, right? But in AlCl4 negative, there are 4 bond pairs plus no lone pair. So in AlCl3, hybridization of aluminium is sp2 because 3. So 3 means 1s and 2p. Okay. And AlCl4 negative 1s and 3p. So sp3, here it is sp2. So there is a change in hybridization from sp2 to sp3. Okay, that's it. So this is the answer of the question, right? Okay, now next question. Question number, okay, this was question number 25. Okay, so now question number 26. Question. Question is there any change? Is there any change in the hybridization of boron and nitrogen, boron and nitrogen atoms as a result of the following reaction. So reaction is BF3 plus NH3 to form BF3 dot NH3. This is called adduct. Okay, so say in BF3 boron is attached to 3 fluorine. Okay, or we can write it like this. Okay, and in NH3 nitrogen is attached to again 3 hydrogens. At the same time it has 1 lone pair. Okay, now boron has vacant orbital. Boron has vacant orbital. Okay beta, I can. And in NH3 this lone pair of electron, say this lone pair, and boron has vacant orbital, it has filled pair of electron, it has unshared pair of electron, it need 1 pair of electron to complete its octet, it can donate. So there is a formation of coordinate bond between boron and nitrogen. It can also be represented like nitrogen with positive charge and boron with negative charge. So these are the ways to represent the coordinate bond. Okay, so now what happened? Tell me, what is the hybridization of boron here? What is the hybridization of boron before the reaction? What is the hybridization of boron before the reaction? See, boron has 3 bonds, so its hybridization is sp2. Am I right? sp2. Very good. And what about nitrogen? What is the hybridization of nitrogen before the reaction? Because there are 3 bond pairs and 1 lone pair. In this case, it has 3 bond pairs plus 1 lone pair. Okay, but here there are only 3 bond pairs, no lone pair. So total 3. So sp2, it is total 4. Very good, Siddharth, Ralam, Anika. Abhay. No, beta Siddharth. There are 3 bond pairs but 1 lone pair. Lone pair is always hybridized. Lone pair is always hybridized. Please keep in mind. Okay, so total 4 electron pairs, right? So it is sp3 hybridized. Very good, Ralam, Anika, Sakshi, very good. Siddharth, okay, very good. So sp2 boron, sp3 nitrogen. Now tell me here. Yes, very good. Boron. Now boron has how many bond pairs? After the reaction, now boron has 4 bond pairs, right? 3 covalent bonds, 1 coordinate bond. Coordinate bond is same as that of covalent bond, okay, once it is formed, and it is treated as bond, okay, pair. Covalent bond, coordinate bond means bond pair, okay. One coordinate bond means one bond pair, okay. So total 4. So hybridization of boron now is sp3. Earlier it was sp2. After the reaction, it is sp3. And what about nitrogen? Now it has 4 bond pairs. Earlier it has 3 bond pairs and 1 lone pair, okay? But now after the reaction, it has all the 4 bond pairs because nitrogen donated its pair to share with boron so that both have complete octet of electron. And this is called adduct formation. This is called adduct formation. Okay, so 4 bond pairs, so it is sp3 hybridized. Okay, so this is question number 26.